two coins are tossed simultaneously. Find the probability of getting at least one head. So let's draw the tree diagram and find the sample space. So two coins. So first coin either a head or tail, and second round or two coins. Let me copy down H, this T. Now I'm going to insert HT alternatively. HT. So when two coins are tossed simultaneously, the sample space will be HH, HT, TS, TH, TT. Okay. So there are 4 equal chances of getting these 4, okay, out of 4. Now it says find the probability of getting at least one head. At least one head means 2 heads is fine, so this is good. HT is fine, TH is also fine. At least one head. Both tails not good, so 3 out of 4. So the answer is 3 out of 4. Okay. Number 12. A die is rolled and a coin is tossed. Okay, these two events are independent. Okay, the result on this event does not affect the result on the second event. Okay, so find the probability that the die shows an even number and the coin shows a head. So let me show you 2 ways to solve this problem. So the die shows an even number, so probability of even number on die, so even number on die, and coin shows a head on coin. Okay, that is same as, because these two things are independent, that's getting that same as probability of even number on die times head on coin. So probability of head on coin, so that is equal to, so what is the probability of even number on die? So on a die there are 6 sides and there are 3 even numbers, 2, 4, 6, so 3 out of 6 chances, which is 1/2, times probability of head on coin. There are 2 faces, 2 sides on a coin and 1 head, so this is also 1/2, by the way. 3, 6 is same as 1/2 times 1/2, which is 1 times, okay, I'm just cancelling, writing 1/2. 1/2, 1 times 1 over 2 times 2, 4, so 1/4 chance. Okay, this is one way. Alternatively, you can do the following. You can make a chart. Okay, for a die there are 6, so 1, 2, 3, 4, 5, 6, and for a coin there are head and tail. Okay, so first there was a die, so we should have written 1, 2, 3, 4, 5, 6 on this way, same thing. So 1, 2, 3, 4, 5, 6. Now heads and tails. So 1H, 1T, 2H, 2T, 3H, 3T. So there are 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities, and we want to have even number on die and chosen head. So head means 1, 2, 3, 4, 5, 6. So there are 6 ways, but even means 2 heads fine, 4 heads fine, 6 heads fine. Okay, so 3 ways to get even on die and heads on coin. So 3 out of total how many? 12. So 3 over 12, which is same as 3 divides 12 4 times, so 1/4, which is what we got earlier as well. Okay, number 13. If one number is selected randomly from the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, find the probability of each of the following events. The number is odd or could be more, or a multiple of 4. So there are 10 ways, 10 elements in this sample space, so 10 goes on the bottom. Now we are good if we get an odd or a multiple of 4, but we should not count, we should not double count. Okay, odd number, odd means 1, 3, 5, 7, 9. So there are 5 odd, and multiple of 4, so 4, 8, there are 2, so 5 plus 2, 7. So there are 7 of these, so 7 out of 10 is the answer. Part B, from the same sample space, okay, from the same sample space, so there are 10 members, 10 numbers, so 10 goes on the bottom. We need to find a number which is odd or multiple of 3. So odd, again, 1, 3, 5, 7, 9. So 1, 2, 3, 4, 5. And multiple of 3, multiple of 3 means 3, 6, 9. But we should not count 3 and 9 because they are already included in odd numbers. So the new contribution is 6. 1, 2, 3, 4, 5, 6. So there are 6. There are 6 cases, either odd or multiple of 6, multiple of 3. Okay, so 6. And then finally the last question, number 14. Suppose you are playing a game with a 20-sided die. Okay, it's kind of new. 20-sided die, number 1 through 20, like 1, 2, 3, all the way to 20. Okay, we've seen the regular die with 6 faces, 6 sides. Now we got 20-sided die. If you roll the die twice, so roll, what is the probability that you would roll a 3 first, then a 15? Okay, so probability of 3 first and getting 15 in the second round. Okay, these two events are independent because when you roll, so there are 20 equal chances, roll again another 20 chances, so these are independent. So that's same as P of getting 3 times, and means times P of 15. Okay, so that's probability of getting 3. So there is only one 3, so 1 chance out of 20, 1 out of 20. And probability of rolling 15, there is only 1 15. Okay, it's 1 out of 20 chances, 1 over 20. You multiply 1 times 1, 1 over 20 times 20, 400. Answer. Okay, next question. If you roll the die once, just once, what is that? Means there are 20 equal chances. What is the probability that you roll a 6 given that you roll an even number? Oh, given that, so it's already given, so our sample space will be smaller than this, not 1 all the way to 20. Okay, it's conditional, there is a condition given. Given that you roll an even number, someone told you you rolled an even number. So even number means it should be either 2, 4, 6, 8 all the way to 20. So how many numbers are there? So if we count all of them 1 through 20, now we are counting 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So there are 10 numbers, so 10 and 6, there is only one 6, so 1 out of 10 chance. Okay, final.